In a right triangle, the measure of one acute angle is pi over 6 radians. What is the value of the tangent of that angle? Well, I know it mentions right triangle, but I'm going to view this from the viewpoint of a unit circle, because if you remember, the unit circle gives you parts of a right triangle. There we are. And so the angle that it gives me is pi over 6. Pi over 6 is like right here. Now, I can view this as a right triangle if I call u y and if I call this part x. But most importantly, the angle is pi over 6. Now, if you remember from the unit circle is split up into dot, 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 dot. This is 0, and this is pi, which means pi over 6 is that first dot that I have right there. Now, that gives me the coordinate root 3 over 2, 1/2. Now, tangent of theta is given to us by y over x. I know that because tangent is sine over cosine, and if I do a little bit of simplifying, I end up with y over x. So in this case, tangent of theta is going to represent 1/2 over root 3 over 2. So tangent of pi over 6 is going to be 1/2 of root 3 over 2. Now, whenever you have a fraction divided by a fraction, multiply the top and the bottom by the reciprocal of the denominator fraction. So 2 over root 3 over 2 over root 3. That allows me to completely clear out the entire bottom. And it just so happens that these 2's cancel out as well. That leaves me with 1 over root 3. Now, you were probably taught back in the day that you should never have square roots in the denominator, so we rationalize the denominator by multiplying the top and the bottom, the numerator and the denominator, by root 3 and root 3. 1 times root 3 is root 3. Square root of 3 times the square root of 3 is the same thing as the square root of 3 squared, in which case the square and the square root cancel each other out, and we're left with the square root of 3 over regular 3. So yeah, there you go. That's the tangent of pi over 6. Fun stuff.